Hello, everyone. Hello, and welcome to today's webinar. This is part 3 of our current series, Leverage the Power of Design Structural Work Suite. We are led today by Seth Guthrie, our RAM and STAAD product expert and Director of Product Management. Seth has been working with Bentley structural product for the past 25 years now, and we are lucky to have his vast knowledge and expertise leading this Bentley team today. Thank you all for joining us, and I'll pass it now along to Seth for his presentation.
Thank you, Pietro, for that intro. As he was saying, I'm now the Director of Product Management for all the structural products. That includes the RAM products, also the STAAD products, which is everything that is included in the structural work suite that you're here to learn about. I also am the product manager for a project called ADINA, which is a structural analysis application, a general purpose finite element analysis tool with solid modeling and nonlinear behavior. But today I'm going to focus mostly on topics related to steel design, and I'm going to use 3 of the RAM applications to show you the latest codes, the application of those codes in the products, and a little bit about the seismic provisions as well. I have been working with RAM for 25 years, mostly in tech support. In the last couple of years, switched to product management. Some of you may have used the product in the past and known the previous product manager, Alan Adams, who retired last year after over 30 years working on the RAM structural system. I also serve on the AISC Seismic Design Manual Committee. And if anybody wants to hit me up, I'm seth.guthrie@bentley.com, or you can find me on all of our forums and various locations. And I need to update my picture because that's a few years old. You can all see. All right, so I mentioned that we're going to mostly talk about changes in the steel code, changes in the seismic provisions, and how those are in our software. I'll show you a couple of methods within the software to compare. And just point out some of the changes. They're not sweeping changes with the 2022 code, but there's a few things to be aware of. And I guess what I'm trying to emphasize here is that at Bentley, we stay on top of the codes and try to get them out as soon as possible to all of our users. I'm also going to show a little bit about connection design. In case you haven't seen that, RAM connection is integrated both with RAM and with STAAD, and it's included in the structural work suite. I just put this slide in here because I happen to have access to the mission statement for AISC's committees, and it's a lot of parallels with the mission statement of Bentley Systems. We're here to provide innovative software to help advance infrastructure engineering. I personally involved in structural engineering, but that includes civil engineering to a degree, and we're very keen to provide software that helps to economize and make structures that are resilient, cost-effective, and socially responsible, environmentally responsible, in fact. So that's what we're about, in case you didn't know. Okay, the first change in the steel manual is, of course, some new sections. These will be in the beginning part of the manual. There are some new heavy shapes. These are very deep, very thin sections that work for beams, especially for deflection. I'll show a couple of examples of this in the structural system. There's also a wide range of new HSS shapes with even thicker flanges or sides. And I will mention that we also have a separate table of the A1085 HSS shapes. If you're not familiar with that, the HSS basically is split. You can use nominal dimensions, or you can use shapes that are rolled with a greater tolerance that you can count on the thickness more exactly, and therefore use greater stiffness properties for a section by using the A1085 material with a greater quality control. There's also some changes in the manual for the preferred materials. Within the software, the user just specifies the materials they want, but that is, of course, possible to do. There's a couple images from the structural system. I'm going to pull this up in a second and show you the same thing with those new shapes. And with that, I'm going to go ahead and switch now. This is RAM Structural System version 2024. This is about to be released. It includes the codes that I'm talking about here. And look at new master table. We call these the RAM AISC table. There's various tables in the program. One that facilitates beam design, one that is for columns, and one that is just the master table with all of the section properties. Works fairly simply. You can see in here within the W's, we have some of those new. Let's see, it seems like about 40. Seems like one of these was new. And double-clicking it, you can review all the properties for those sections. We update these every time the manual is republished. And then within the beam table, the sections are ordered for optimization. And this is within the user control. So if there's sections that you don't want to use, you can just turn them off. And then in the column design, everything's categorized and grouped into groups that make sense for columns. Here's the new 20 by 20s, for example, and there's this 20 by 20 by 1 inch section that's new. All right, let's take a look at some column design. In column design already. Right. For column design, got your design codes. You can see the latest steel code there. And in one of these, you can look at some of the larger shapes. This structure doesn't really warrant the 20 by 20 by 1 inch, 20 by 20 by 3/8, or even a 10 by 10 by 5/8 would be more economical. But you could pick the different shapes, including those extra large ones. Select it if you wanted to. It's a bit over designed. All right, let me show you one other thing in the structural system before I switch away. This is a bit of the beam design. One warning, everything else worked. This is a very long span, very heavily loaded member, but like 500 pounds per square foot on there. And this particular case, the previous size was a 36-387. It's not passing my stringent deflection criteria currently, but if I optimize it, then the program will find one of these new shapes that's deeper with about the same weight that performs better for deflection. So it's got greater inertia. And if you like that one, you can update the database and then it'll pass. All right. Okay, the next change in the manual will be in chapter D. There was a small change in how we handle the shear lag coefficient for welded HSS or pipe, usually in braces where they have a slotted connection and they're in tension. And basically, the change is that there is no longer a strict limit on the length of the weld. If you have enough capacity, you have enough capacity. So there's no longer this requirement that the length of the weld be greater than or equal to D. And we can see that in our programs. I'll show you that in just a minute, where you can still do a design with a short weld along the length of a brace. There's an image of it, and I'll, like I say, I'll pull that up live in just a second. Okay, the next change is in chapter E. In chapter E, there is some new provisions for axial compression. This is really for beams or fairly slender type of members that might be subject to compression. So the example that's commonly cited is the collector beam or the cord of some sort of truss or something, where it's a beam primarily taking flexure, but it also has some compression. And the change in the code was to permit some eccentricity in the bracing location. So lateral torsional buckling traditionally has just been buckling about the centroid of the beam, like so. But it's quite possible that the bracing would be from a deck or some purlins that are eccentric to the centroid of the section. And when you do that, then the failure mode isn't a pivoting about the centroid, but it's a pivoting about the brace point. And that gives you a slightly different lateral torsional buckling capacity. So there's new equations for this. There's equation E4-10 and then E4-12. These have been implemented in RAM Elements and in STAAD.Pro and any of the products that have the latest steel design for the most part. I'm going to show it to you in RAM Elements where it's easiest to illustrate the user definition of the YA term and the XA term. There's also a change in the design of stiffened girders. There was a change in how we handled the end shear, the shear in the last bay, what they call end web panels. And I think I can show you that as well. So let me switch over to RAM Elements. Where is it? Okay, let's start with the off-axis bracing condition. The way it works in RAM Elements, all of the member steel parameters are entered into the spreadsheet. There's a list of them here. It's growing because there's more and more special conditions in AISC, but the thing we're looking for here is called XA and YA offset values. What I've done here is I've taken a W12 member, so it's got about 6 inches between its centroid and its top flange, and assume that I have, in this case, 5 extra inches up to the centroid of the purlins, where the plane of the bracing is affected. So an 11-inch total YA value. And if I design that one now, and I design it according to the 22 code, which is here, then I can look at output with the steel design. Screen. And in the design checks for axial compression, we're talking about compression buckling in the minor axis, and here's the details of the equation for the torsional or lateral torsional buckling stress. It doesn't control in too many cases. It actually tends to improve performance having the eccentricity, but it's one of the most important changes in the 2022 code. There's a nice paper by Will Jacobs on the topic. If you want to read more about that, just look for constrained axis torsional buckling. While I'm in RAM Elements, I'll show you here one of these connection designs. I mentioned that connection design is integrated, so you can apply a connection to the end of a member, whether it be in RAM Structural System or Elements or STAAD.Pro. And this is that weld length that I mentioned before. We can make that weld length shorter, and it would still we could still pass code. Whereas in the previous edition, if that length became less than the depth of the member, we would have just gotten a fail. Let's see. That's the right brace. That's the weld length. Still passes. Okay, switch back to the presentation. The next change is in connection design, and it is in welds. This is a pretty significant one for RAM connection. There was a change in how welds were handled when the direction of the force was not parallel to the weld nor perpendicular to the weld. And so for a lot of conditions in RAM connection, we're dealing with a weld that is loaded in shear and it's being pulled in tension, or it's there's some eccentricity causing a moment, various conditions that trigger this. And we now have a new factor, a K sub ds factor that we calculate based on the trigonometry, based on the direction of the loads relative to the direction of the weld. So we put this in, and this will make some changes in your connection capacity with various types of connections. There's just a static image, but I will switch. Same problem as before. I gotta reopen it. All right, so this is the standalone version of RAM connection. Before I showed you RAM connection running inside of RAM elements. This will just be the standalone version. The only difference really is that in the standalone version of RAM connection, the user defines the joint. What are the members that are framing together and what are the loads? In the integrated versions, we take that information from the main model. We know that it's a particular beam size, a particular column size. We know what all the forces are for all the load combinations and so forth. This is a demo file. Here's an example of a welded connection. This is a moment end plate extended one. And that weld, as you can imagine, is subject to combined forces. It's loaded in shear. It might have some axial force, and it certainly has bending. So those forces are going to resolve in some different angles. Right now, I am designing this in the 2022 code. And if I look at the design, it's passing, and I can look at the results. And down here in the beam check is the weld. And if I look at the formula, you can see right here is the calculation of the K sub ds. In this case, beneficial. If K sub ds is greater than 1, I'm getting additional capacity because that load is applied at an angle to the bricks, to the weld. Just to demonstrate in RAM elements, or excuse me, in RAM connection, we have recently added this so that you can change it right here in the main view, and then you can recheck the same joint. I don't think that even affected the capacity because the capacity was probably controlled by the bolts. But if I look at the results now, it would be slightly different in that section for beams. All right. One more thing that I want to talk about here in RAM connection that's fairly new and kind of exciting for us is we have this new design verification test tool. We have been doing QA on our software for years and years. We have builds that run every night or several times a week. And when we go through the build process, we run a whole bunch of automated tests. We verify that the answers are correct and that they're still what they were before. And when things change, perhaps because the code changed or because we've just detected a defect and fixed it, then we can update our automated tests. Well, a lot of users were looking for this kind of functionality in software that they could run themselves to rule out any possibility of getting different results because the hardware is different. Don't know why that would happen, but it theoretically could happen. So we have provided the full set of results as well as the documented correct answers. And in the help, you can find the verification manual as a PDF. That will tell you, in text form, all of the different tests that we have performed for all the different codes, what the expected results were, what the program result was, and any deviation, which is bound to happen due to rounding. In addition to that text form now, we have provided this utility which you can use to run specific problems or a suite of problems. And in this case, you've got multiple design codes I mentioned. And within the AISC, you've got 30 or 40 different examples that have been run, and we produce the right results for. And simply, you run this entire set. It takes a few minutes, and it would run every one of those problems, verify that the results are still equal to the expected result, and then report if there was anything that was amiss. I won't run it now, but I'll just show you in the slideshow then a bit about the tool. What happens then is as it goes through every one, you can click on it, see that same results table, and then we use a coloration scheme, green being it's still a match. So that's a pretty exciting feature for us. And we will probably be putting similar kind of functionality in other products. STAAD.Pro is another one where we have many verification examples, different problems. And since the analysis results there are subject to the finite elements analysis, you tend to see a very slight deviation due to improvements in the finite elements analysis, the methods there. So the last thing I want to show, I don't have any particular slides for this, but I do want to talk just a little bit about the seismic provisions. In addition to the change for AISC 360.22, there was also an AISC 341.22 seismic provisions that were implemented in the same year. Seismic provisions are something that we have in RAM structural system. We have it in RAM connection, to agree in STAAD.Pro as well. I'm most familiar with how it's implemented in the structural system, so I'm going to use that today. If you're not familiar with the RAM structural system, the general workflow is to design the gravity framing first, then to perform a lateral analysis on the lateral skeleton. In this case, you can see that we have this fairly complicated model with hundreds or thousands of beams in total, but many of them are just gravity beams, just imposing a reaction and providing a brace point onto the frame members. So in the lateral analysis, we don't really need all of those members. We can simplify our model down to frames that are tied by rigid diaphragms. And that's fundamentally one of the things that we've always done with the structural system. So that's my lateral model, that's my finite element model. In this case, these are special moment frames, and they happen to be using the side plate moment connection. We have several different custom types of connections that you can assign. For beams, you can assign side plates, Durafuse, yield link, and then for braced frames, we have a bunch of different buckling restrained braced frame types like core brace. From the analysis, we've got notional loads in here, wind and seismic as well. I think this model is running with the 2016 AISC 7. We'll be updating that to the 22 version as well. Okay. And second phase then is standard provisions, steel design, generate a bunch of load combinations, and then the seismic provisions. So if you haven't seen this, the seismic provisions we have been doing since, I guess 20 some years now as well. The first version was 1997, now we're up to the 2022 code of 341. And this is the part that's near and dear to my heart because it's the committees that I'm serving on. We have seismic provisions here for special moment frames with the side plate connections. We also do buckling restrained brace frames, as I mentioned, standard, ordinary, concentrically braced frames, chevrons, intermediate moment frames, ordinary moment frames, you name it. A lot of load combinations, a lot of members. Take a minute. With the beams and the special moment frames, the most critical condition is usually just the slenderness. There's requirements for the beam to be compact, and these limits on unbraced length tend to be more strict than you get in other types of frames. You've also got your general column to beam capacity ratios, this notion of a strong column versus a weak beam in special moment frames. And then with the side plates, there's some custom design that's done for side plate connections. This is actually the very latest report engine that we're using with the structural system. It's going to have some new advantages for users that you can jump to various spots in the report, very similar to what I showed in my connection a minute ago. But this one's passing. He has met that ductility limit. Unbraced length is satisfied, as are the B over T and H over TW ratios. All right, I told you the changes weren't too sweeping. I have reached the end of the topics that I really wanted to talk about today.